Are you new to the Elastic Stack? In this video, I'm going to walk through the installation of Elasticsearch and Kibana on Ubuntu, as well as give you some tips on how I configure those applications for the best performance and reliability. Hi, I'm Rob Cowart, and many of you probably know me as the creator of Elastaflow, as well as some other solutions that I share on GitHub that are based on the Elastic Stack. Now, when I first created these solutions, my assumption really was that most of the users would be existing Elastic users that were actually looking to my solutions to help them get a head start on some new data sources. I was actually pretty surprised to find that many of the users, it appears, are new to the Elastic Stack. They actually came to my solutions for the value they provide, but they really need some help to get started. So what I want to do in this video is help those of you out there that are new to the Elastic Stack to take those first few steps. And that starts by installing the two core applications, which are Elasticsearch and Kibana. Now, we're going to install those natively on top of Ubuntu in this video. So one of the first things we need to talk about is the hardware resources you're going to need. Now, the Elastic Stack can run on fairly modest hardware for experimentation and development purposes. In fact, most modern laptops will suffice as long as you have about 16 gig of RAM and ideally SSD storage. However, if you're going to have a permanent lab environment where you're going to have at least moderate to even larger amounts of data coming in, and to give you an idea what I mean when I say moderate to larger amounts, we're thinking like anywhere from 20 to maybe a couple hundred events per second, I would probably recommend you start with something like 4-core CPU, 32 gig of RAM, and of course local SSD storage. The actual hardware resources you're going to require depend on a lot of factors. So it really is going to depend a lot on the use cases. Elasticsearch can be used for pure search type use cases, thinking like website search and those type of things. And that can oftentimes be a completely different hardware requirement for like data sources that have real-time high volume ingest requirements like firewall logs or network flow records like IPFix or NetFlow. So I'm going to focus on more of these high volume sources because that really reflects a lot of the projects that I've worked on, as well as the solutions that I mentioned earlier that I provide on GitHub. In the many projects that I've taken part in over the last few years, I've really learned a lot of lessons, and those lessons really shape my recommendations when it comes to hardware, as well as the configuration settings that we're going to get into later. And in some ways, my recommendations are going to differ a little bit from what you might hear from Elastic themselves. My experience is Elastic just tends to generalize and picks a middle point for the various different use cases where the stack can be used, and that's okay. I understand their thinking there. However, my recommendations are a little bit more specific to the high volume log and similar type use cases. Kind of the standard server that Elastic's going to recommend is they'll say around 8 CPU cores, 64 gig of RAM, and local SSD storage. We'll talk a little bit about storage in more depth later, but if it's something that's interesting to you, I've done another video where I specifically dug into the details of the best types of storage for Elasticsearch, and you can find a link to that video up above. So let's start by talking about CPUs. Now, when I talk about CPU cores, I mean real cores. I'm not talking about hyper-threading threads in virtualized environments. I'm not talking about vCPUs. In fact, if I say a recommendation is 8 cores, if you're going to be in a virtualized or cloud environment, I generally recommend that you double that number for the number of vCPUs so you can make sure you have sufficient resources. Indexing data can be a very CPU-intensive task. On top of that, various types of queries can also add significant CPU load. Now, I generally find that if you want to provide a good experience to the users and ensure that they enjoy actively using the system, you're going to want to make sure that queries perform pretty well. Part of that is just related to storage and some other things about how we set up memory. We'll talk about those details in a second. But a big part of it also is making sure that there's sufficient CPU resources available to handle the query load that you're running against the system. I generally like to recommend at least 12 CPUs as opposed to the 8 that is generally recommended by Elastic, simply to make sure that there's some additional headroom to ensure a good user experience. In regards to memory, more memory is almost always a good thing. The reason for that is that the Linux kernel will tend to use any extra available memory as page cache, and that page cache serves as a cache of all of the disk I/O. So whenever you're doing time-bound queries of recent data, so things like last 15 minutes, last 30 minutes, last hour, if that data is in RAM, in the page cache, you're going to be able to access that data for queries without actually initiating any disk I/O, any additional reads. And that's going to really increase performance and increase the user experience. So the more memory you can give the server, generally it's going to be better, as opposed to the normal 64 gigabytes that Elastic would recommend. I really like my nodes that are doing both ingest and handling the queries to be around 96 gig as a starting point. Now, I have a real clear message when it comes to storage, and that is you must use local SSDs, period. I can't tell you how many times I've had users come to me and they have plenty of CPU, they have plenty of memory, but they're really struggling with the performance, being able to handle even a moderate load of events because of the storage that they have. Typically what we're talking about is maybe 4 to 8 hard drives, so spinning hard drives, maybe in a RAID 0, that's probably the best bet. Probably if they're on a single node because they want some redundancy, they have a RAID 10 set up, but really bad would be something like a RAID 5 or a RAID 6, which is just legendary for horrible write performance. And in these situations, they're almost always I/O bound or IOPS bound on the storage side. And so like I say, I just can't overstress how important it is to have SSDs. Now, whether those SSDs are NVMe or they're like SATA SAS type drives, that's a little bit less important. But the clear message is this: SSDs just have a huge advantage over hard drives, and they're going to affect or improve your user experience so greatly that I just can't recommend strongly enough that you go that route. It's in every way worth the extra expense. And nowadays, as SSD storage has come down, it's really not that expensive nowadays to get 6 to 8 terabytes of SSD storage, even in moderate servers. We're talking about ideally 12 real CPU cores, 96 gig of RAM, and 6 to 8 terabytes of SSD-based storage. Of course, it is possible that you might even exceed the demands of that type of server or that hardware. And in that case, what you're really going to need to do is build a multi-node cluster of Elasticsearch. In this video, we are focusing on a single node install. In a future video, I'll actually talk about how you can build a multi-node cluster, and then we'll take a look at what the advantages are of that type of setup, including both reliability and additional performance. So let's get to the install. The Elastic documentation does provide all the steps that you're going to need, and we're going to walk through those now step by step, and then I'm going to show you how I customize that starting point, customize that default configuration for better performance and reliability. So just a little bit more details on the starting point. I'm using Ubuntu 18.04, the LTS release, so long-term support release. It has been updated using an apt update, apt upgrade. It was a minimum install, so there's really no extra components that need to be installed. And for the purpose of this video, I did disable AppArmor as well as the firewall, just to prevent those things from being in the way of like opening ports and network connections and things of that nature. I actually have another video planned for the future where I'll go into all the detailed steps to fully secure your Elastic implementation, but we're not going to cover those details here. So at the time of this video, the current version of the Elastic Stack is 7.6.0. Now, one of the changes that happened with the Elasticsearch 7 release is that you no longer have to install your own Java JDK, your Java runtime environment. There actually is a Java runtime environment that comes pre-bundled with Elasticsearch now. Now, you do have the option to override that by setting the Java home environment variable. However, for most cases, I've actually had pretty good experience using just that current pre-bundled Java environment. So let's go ahead and get to the install. Elastic signs all of its packages with a PGP key. So the first thing we're going to need to do is download that key and add it to our system using app key add. Additionally, we will be retrieving all the packages via HTTPS, so we'll also need the apt transport HTTPS package. Next, we need to set up the Elastic Debian repository. Now, Elastic actually provides two different repositories. One of those provides all the packages that include xpac, pre-bundled. The other is the pure Apache 2 licensed packages. Now, in this video, we're going to use those standard packages, standard distribution, because we're going to leverage the security features and include it as xpac basic, so that you have basic user authentication. So to set up the repository, we're going to run the following command. Now we'll run apt update to update the local package cache. And we can install Elasticsearch by running apt install Elasticsearch. At this point, we could just start the Elasticsearch server using the default settings and have something that would work for like a local kind of development environment on a laptop. However, we want to set this up so that the system can actually be accessed externally from other hosts, as well as tune it a bit for better performance and reliability. The first thing we need to do is configure the JVM heap size. You're going to need to edit the file etc elasticsearch jvm.options, and you're going to find two values in here that we need to change. One of them is indicated by the value xms and the other xmx. What these are the initial and the max heap size that we want allocated for Elasticsearch. Typically, the recommendations for heap size are to use about half of the available system memory. However, you always want to make sure that you never cross 32 gig of heap size. There's actually some internal ways that the JVM handles memory that can really be detrimental if you go over that 32 gig limit. And in fact, many say that it's better to ensure you don't go over it by keeping it to around 30 or 31 gig is at the absolute max heap size. That works out with my recommendations of about 96 gig of memory to be about a third of the available system memory. And that's where I tend to set it in most environments. So, if you have a system that has 32 gig of memory, I'm probably setting that value to around 10, 11, maybe 12 gig, a little bit more than a third, but certainly not up to half. So that would be kind of typical of a lab environment. Maybe on your laptop, if you have like a 16 gig laptop, maybe you'd go somewhere around 6 gig, kind of splitting, but a little bit less than the 8, which would be the half mark. This particular system that I'm installing on, I have 32 gig of RAM, but because I have Logstash, or I want to have room for Logstash, which can also require significant heat in some use cases, I'm going to go ahead and set it to 8 gig. So the next thing we need to do is increase some of the system limits from the Linux defaults. I like to do this in a systemd configuration file specific for the Elasticsearch service. So what we're going to need to do is create a new file in our systemd directories. So first let's create a subdirectory. So we're going to create a etc systemd system elasticsearch.service.d. And in that directory, we're going to create a file called elasticsearch.conf. Into that file, we're going to want to put the following options, and let's walk through these one by one. Elasticsearch uses a lot of files. If you think about all indexes are composed of shards, and all shards are composed of segments, and segments are basically files. Now, segments do get merged over time and can actually be force merged to control or minimize the number of files that are required. However, you're still generally going to end up with a pretty large number of files that Elasticsearch may have open at any time. So what we need to do to ensure that we don't run out of file descriptors, which oftentimes will cause data loss, we need to increase that limit to at least about 65K, and I actually like to double it from that baseline. Elasticsearch also uses a lot of thread pools, and it really needs the freedom to be able to create new threads as needed. So that's another setting we want to increase. Typically, it needs to be at least about 4K, and I actually, again, like to double that to at least 8K. One of the settings that we're going to use later in our Elasticsearch config file is a setting called bootstrap.memorylock. Now, what this setting does is it requests of the operating system to lock the process's memory into RAM as opposed to being swapped out to disk. Because if when the JVM does a garbage collection, it's actually going to access all of the pages of the heap. And if those pages happen to be swapped out to disk, then those pages will have to be swapped back into real physical memory in order to complete the garbage collection. So that additional disk I/O can impact performance pretty significantly. So by locking the JVM and RAM, we can, or the memory of the process in RAM, we can prevent that swapping from happening. So what we want to do is we want to set the memory lock to unlimited. Now, I mentioned before that Elasticsearch can open up a lot of files. And these are both segments, which make up the shards, and there's also something called translog generations that make up the transaction log. And these files can grow to be many gigabytes in size. So it's really important that the operating system is configured to allow for very large files. Otherwise, you can end up with situations where write limits or write failures can occur. So we also want to set the allowed file size to unlimited. Elasticsearch will store portions of the indexes in the Elasticsearch process's address space. It does this to still provide fast access by reading the information from RAM, but at the same time, it reduces the utilization of the JVM's heap. To be most effective, it's important that we also make the address space available to Elasticsearch to be unlimited. Finally, Elasticsearch uses a mmapfs directory by default to store all indices. The default operating system mmap limit is probably going to be too low for a fairly busy Elasticsearch server. And as a result, you could run into situations where you have out-of-memory exceptions. You're going to want to increase the max map count. So we're going to add a new file into etc sysctl.d. And in that, we're going to put the max map count setting to the 256K value that we want. So let's move on to configuring Elasticsearch. The location of the configuration file is in etc Elasticsearch, and the name of the file is elasticsearch.yaml or YML. You're going to find in the default file, there's only two settings. One of them is for the location of the data, var lib Elasticsearch, and the other is for the location of the logs, var log Elasticsearch. Elasticsearch will use the defaults for any setting that is not included in the Elasticsearch YAML file. However, I like to be a little bit more explicit with some settings. So in addition to some that are going to be required, I'm also going to set a few things explicitly, even though they're really just using the default values. So let's go ahead and edit the file. And I'm going to go ahead and paste in the settings, and then we can walk through these one by one. So the first thing we want to set is the name of our cluster. In this case, I'm just calling it lab. You can also set the node name. Typically, that would be the host name, and if you don't set it, it will default to the host name, but you may have a need to set it to some other value that's of meaning to you. Path data and the path log directories were set in the initial file. We're going to leave those as what the defaults are. I mentioned earlier in the talk about memory about the bootstrap.memorylock true, and that's the setting we have here. That's going to ensure that none of the heap or Elasticsearch process memory gets swapped out to disk. And we have to set up our network. So by default, Elasticsearch is going to listen just on localhost. Because we want to have access to it from other systems, we're going to need to change this to set it to all zeros, so 0.0.0.0. And we can leave the default port of 9200. Now, if we were setting up a multi-node cluster, we'd have a number of other settings that we would need to make in order to ensure communications around the whole cluster, including if we're going to be leveraging some of the xpac security features, including making sure that we've set up TLS-based encryption for at least the internode communications. However, in this particular case, we just have a single server. So there's a kind of a shortcut where we simply set the setting discovery type as single node, and we don't have to set those other settings. Now, these next two values differ pretty significantly from the Elasticsearch defaults. This is this indices query Boolean max clause count. I'd like to bump that up to about 8K, specific to the type of use cases that I'm working in. So again, we're talking about different types of logs and network flows where we may be dealing with some high cardinality data, so really large numbers of IP addresses and things of that nature. And that really can make this max clause count setting pretty important. In addition to that is the max buckets. So this also gets raised pretty considerably from the defaults. And the reason for that, again, is having high cardinality data sets, and some of the queries that are going to be done in our Kibana dashboards potentially might have a lot of buckets, especially like, let's say that we have a graph that has a time period across which there's maybe 2,000 buckets, and we actually want to show 100 different entities, so maybe 100 different, like the top 100 IP addresses in that particular chart. Now we have 100 times 2,000 buckets, that's 200,000 buckets. And if we don't set this max bucket value higher as we have here, we're going to get into some issues in some of the queries that are going to be interesting for the use cases that I use. So both of these settings are pretty important to these security log, network flow type use cases, and the high cardinality data set that they represent. I want to take a quick break to say that if you're getting some value out of this video, please hit the like button below. And if you're interested in content like this in the future, hit subscribe so that you can follow along on the channel. The next setting I want you to make sure you have set is the destructive requires name true. Basically, Elasticsearch, if this setting is false, Elasticsearch will allow you to do something like delete all or delete star for an index name, and you could end up deleting not only all of the indices that contain data, but deleting indices for your security, user accounts and stuff in Elasticsearch, your Kibana dashboards, pretty much everything. So to ensure that you don't make any mistakes where you accidentally delete data you didn't intend to, I highly recommend setting destructive requires name to true, because then you'll have to explicitly indicate each index that you want to delete. Sometimes during maintenance tasks, that can be a little bit of a pain to do that. However, with some clever scripting, you can also automate that process in a way that's a bit safer. The next setting you might not need, this reindex remote whitelist. What this is a whitelist of IP addresses and port numbers from which this Elasticsearch server is allowed to remotely access data to reindex. So let's say I have another Elasticsearch cluster and it has some existing data in it, and I want to reindex some of that data into this Elasticsearch server. Then I would either have to explicitly have that IP address in this particular setting here, or in this case, I'm just using these wildcards that allow me to reindex from anywhere. Now in production, you might not want this setting set this way. However, in lab environments, I find I end up moving data around quite often for various experiments and other reasons. And so it's one of my standard settings for most systems that I set up, although some production environments where you want to lock it down a little more, I might leave this out. So next we're going to get into configuring xpac. So as I mentioned earlier during the install, we did leverage the Elastic licensed repositories that have the standard distribution, which includes xpac pre-bundled, and the xpac basic license is available to you at no cost to use in perpetuity, really. So there's, if you want security features out of the box that are well integrated, it's definitely worth leveraging the xpac basic security features and configuring xpac. One of the things xpac includes is monitoring, so the ability to monitor the state of the cluster. Now, by default, monitoring is going to be collecting metrics from the Elasticsearch server every 10 seconds. I really don't personally need that granularity. It doesn't provide a lot of value to me, so I like to bump that up to 30 seconds, as well as ensure that collection is enabled. Next, we want to configure security itself. So we want to set security enabled to true. However, I'm not really interested in audit logs. That may be something that's important to you, especially in a production environment, in a lab environment. You probably do not need them. Audit logs can actually generate quite a large volume of data, depending how things are exactly set up. And so you may need them, but just be warned of the data volume. I personally am not too interested in them in most of my environments, although in some customer projects I've done in the past, we have had them enabled. But in this case, we're going to go ahead and set those to false. Now, because we're only leveraging xpac Basic, we will not have a license for the machine learning features, so we can go ahead and set node ML to false as well as ML enabled to false. Similarly, Watcher is also set to false. Watcher's kind of the alerting capability of xpac. And although the defaults for index lifecycle management and the SQL query features of xpac are by default to true, again, I do like to explicitly set some things, and those values are set to true in this case as well. So now we just need to save our configuration file. And at this point, we can go ahead and start Elasticsearch. So we're going to do a systemctl daemon reload first, and we can also now do a systemctl start Elasticsearch. If you want to check on the status of the daemon running in the background, go ahead and do a systemctl status Elasticsearch to see the status. So now we can go over to our browser and go ahead and put in the IP address of the system where Elasticsearch is running. And then the port number for the REST interface to Elasticsearch, 9200. Now, because we are using the standard distribution and we set security enabled to true, you're going to be asked for a username and password. However, we haven't set one of those yet. So if you hit cancel, you're going to see an error pop up in the browser with a security exception. So let's go ahead and deal with that by setting up some passwords for the default service accounts in Elasticsearch. To set these passwords, we're going to need to run a process that's provided with Elasticsearch. So we're going to do a user share Elasticsearch bin, Elasticsearch setup passwords, space interactive. And what this is going to allow us to do is set for each of the service accounts. It'll walk through each service account and be able to set passwords. Now, you'll notice when you type in these passwords, they are not going to display on the screen, and you're going to have to enter them twice to verify that the correct password or that a matching password has been entered. If you do make a mistake, you will get an error, and you're going to have the opportunity then to re-enter or correct that password. After you're finished with that, we can go back over to our browser. And again, when we're asked, go ahead and put in the Elastic username and the password that you chose for the Elastic user. And now, instead of an error, you should see a little JSON structure pop up that provides you some information about the node that you've connected to, as well as the cluster and things like the Elasticsearch version, build, and some other information. So if you see that, then you have everything set up correctly. The final step is to go ahead and run a systemctl enable Elasticsearch so that it will run automatically whenever the system is started. And we can move on to Kibana. Since we already set up the repository back when we installed Elasticsearch, we don't need to do so again. That repository contains all of the Elastic Stack packages. So all we need to do now is run apt install Kibana. Now on my system, I actually saw that around 17%, it actually kind of gets stuck for a while. If the same thing happens to you, be patient. It probably sat there for about 5 minutes. I'm not sure exactly what it's doing behind the scenes at that point. There are a lot of very small files that make up Kibana, and sometimes opening and writing those files to the file system can take a bit of time. Perhaps that's what's happening behind the scenes. Go ahead and be patient. It should complete without error given a few minutes. Once Kibana is installed, just like with Elasticsearch, we now need to configure it. The config file for Kibana can be found in etc Kibana, and the name of the file is kibana.yaml. So let's go ahead and open that up in VI. Now, you're going to notice here, just like with Elasticsearch, there's not very much set. In fact, there is nothing set in the default Kibana configuration file. So we're going to go ahead and remove all the default information and paste in a configuration file, and we'll walk through each of these settings one by one. So we start out with the name of the server. This again would typically default to the host name where Kibana is running, but you can set this to some other value if it makes sense for your environment. And also by default, Kibana is going to listen on localhost, which might be okay for development on your laptop. But in this particular case, as we're thinking about a server, we want this to listen on all IP addresses, and we'll leave the port at the default of 5601. One of the really important settings, in particular, if you're going to use any of my solutions that are available on GitHub, I typically see this pop up with the Elasticflow solution. We're going to need to increase the max payload bytes. The primary reason for that is not necessarily with dealing with results of queries, simply based on the fact that there's a pretty significant number of visualizations and dashboards that make up, in particular, the Elasticflow solution, and they are greater than the default 1 meg payload size. So the JSON file, or the HDJSON file, which is the dashboards in that case, simply will not import into a default Kibana environment. And so I recommend increasing the max payload bytes to 8 megabytes. And if you are intending to run Kibana behind a proxy of some sort, say for example Nginx also has a default payload size of 1 megabyte. So you will also need to increase the equivalent value on any proxy you may be using as well. Next, we need to configure the Elasticsearch host. Since we are running on the same node as Elasticsearch, we can go ahead and leave it set to localhost and the port of 9200. That will work just fine. You could alternatively set it to any other IP address on this particular server. And we're also going to need to provide a username and password. This would be the password that you set up for the Kibana user. Two other settings that I feel are really important that deviate from the default are the request timeout and the shard timeout. So by default, these settings are configured in such a way that they will time out all queries after 30 seconds. So if you have queries that take a while to run, are going to return a larger data set, or just going to have to iterate over a number of large indices, they may time out with the default 30 seconds. In particular, again, I'm talking about these really high volume security log or network flow type use cases. It is a situation that can happen, especially if you're not running a multi-node cluster. So I highly recommend you increase the request timeout and the shard timeout from the defaults. I tend to do a 2-minute, or in other words, these values are in milliseconds, so 120,000 milliseconds for the shard timeout. So I like to keep the request timeout just a touch bigger than the shard timeout, about 12K bigger, so 132K. Now the next setting is set to the default .kibana. That's going to be the name of the index where Kibana stores all of its configuration. Then there's a couple of useful settings. They are commented out, but in many implementations, I will uncomment these and set them to specific values. The first being the default app ID. You may want to have a particular dashboard that you've created that gets presented by default as the initial dashboard to your users. And in that case, you would set this value up based similar to how I have here with dashboard /. And if in the URL of the dashboards that you want to show them, you'd find the ID, and you could kind of paste that in here as well and uncomment this item, and you would then launch straight to that particular dashboard. There are a few more settings that are really just set to the defaults. Console enabled, that's going to be a tool that lets you do some interactive queries right from the Kibana interface. And now we can move on to the xpac configuration settings. We are going to ensure that xpac security is set to enabled because we are using xpac basic, as we mentioned earlier. Then we have the Kibana specific monitoring settings. We're going to set the collection interval, which is in milliseconds, to 30,000. The monitoring UI in Kibana can be enabled independently of the collection of metrics. So we want to make sure the monitoring UI is enabled. However, since we're only collecting metrics every 30 seconds, by default, that UI will be set to refresh every 10 seconds, and we don't need it to refresh at that interval. So the minimum would be the actual time that we could receive any data. So let's go ahead and set the minimum interval seconds also at 30. Finally, there's a number of other xpac applications that we could generally just accept the defaults for, but we're going to go ahead and set some explicit values, in this case for APM, for application performance management, setting those to true. xpac also includes a handy grok debugger, and there's also a search profiler that is also part of the console. As we only have the xpac basic license, we can go ahead and set graph enabled to false. And then there are a number of settings for the various infrastructure applications. We do want to go ahead and just set the infrastructure enabled to true. However, at this point in time, I'm not going to change any of the settings. We can just leave those commented out. However, in future videos, as we dig into some of the additional features, we will come back and revisit some of these settings. And finally, we're going to go ahead and set machine learning and reporting to false. Machine learning is a feature of xpac Platinum, and reporting a feature of xpac Gold. The final settings are for spaces, and we will just leave those as the defaults, enabled being true, and the max number of spaces as 1000. And now that we're finished configuring Kibana, we can go ahead and save the configuration file. Previously with Elasticsearch, we just went ahead and started it using systemd. However, there's a few things I want to show you about the startup of Kibana, especially that initial startup. And so instead of using systemd, I first want to start it interactively on the command line. Usually this should just start up. However, I did mention that we were using the new release 7.6.0, and when you start on the command line, you're probably going to pretty quickly see an error, as you can see here on my screen. And it turns out there were a couple bugs that didn't get caught in testing and actually made it into the release. At this point in time, although I really like to have things set explicitly, we need to go ahead and comment out these settings so that they don't get in the way of Kibana starting. So now after saving the file, we can try to start Kibana again. And you're probably going to find we have yet another error. This one looks very similar. In this case, it is the spaces configuration options that are not being allowed. So again, this turns out to be another bug that just didn't get caught in testing in 7.6.0. We need to work around this again, comment out those options, save the file, and now finally we can start Kibana again from the command line. So when Kibana starts, it's going to get to this point where you see this message that says optimizing and caching bundles. So there's a lot of different features of Kibana, some of which we enabled or disabled in our configuration file. And what actually happens behind the scenes is Kibana wants to optimize all of its JavaScript files for the particular packages that are actually active. And so it kind of goes through this optimization phase. If you ever end up installing any plugins and you restart Kibana, you're going to see this same optimization process run. So I just wanted to show you this so you know what it is. There are a number of settings that you may make in your config file that will cause this optimization process to run. And it delays the startup of Kibana. So if you just went and ran, a systemctl start Kibana, and Kibana wasn't immediately available, it very likely is this optimization process running in the background. So again, just wanted to make you aware of it. Now, once the optimization is run, those optimized files are written to disk, and that's what Kibana uses as it's actually running. And between restarts of Kibana, there's no need to re-optimize unless your configuration has changed. So once optimization is done, you should see this message of HTTP server running at the IP address and port number that we specified in our configuration. And we can move over to our browser, and you should be able to now log into Kibana. So in this case, we're going to go ahead and use the username Elastic along with the password that we gave the Elastic user back while we were setting up Elasticsearch. Of course, we don't want Kibana to remain running in just in that terminal window. So let's go ahead and switch back over to the terminal window, hit Control-C to stop the process. And now we can go ahead and run a systemctl start Kibana as well as a systemctl enable Kibana so that it starts automatically when the system is rebooted. So that's it. You now have a running Elasticsearch and Kibana system, and you can begin to get familiar with and start experimenting with the Elastic Stack. I really hope you enjoyed the video. If you got some value out of it, I would really appreciate that you hit the like button. And if you're interested in content like this in the future, go ahead and hit subscribe, and I'll see you in the next video.